Howdy, my name is Michael Barris, and I'm a Principal Solutions Architect with the Amazon Relational Database Service. I'm also joined today by John Gorey and Alistair McDougall from Goldman Sachs Transaction Banking. In this session, What's New in Amazon RDS for Oracle, we'll take a look at features launched in the last year. This session is primarily intended for Oracle DBAs and cloud architects who are already familiar with Amazon RDS for Oracle, but should also be useful for those who are just getting started. And we'll make sure to cover some useful resources at the end to help you on your journey. Today we're going to start with a quick overview of new features. Then we'll take a close look at 3 features I think are important for you to know about: container databases, database activity streams, and replica switchover. Finally, we'll hear directly from our customers at Goldman Sachs and how RDS has helped them to move quickly in the cloud. So let's start with an overview of new features, starting with Oracle feature support. Amazon RDS continues to be a popular place for customers to run Oracle Application Express workloads. So we make sure to stay up to date so that customers have access to the latest features and bug fixes, with versions 20.2 and 21.1 launched this year. Many customers also use Oracle Enterprise Manager Cloud Control to monitor and administer their databases, so we stay up to date on that as well, and have released support for agents 13.4 and 13.5. In most cases, you'll need to keep the Oracle Management Server and OEM agent at the same version for proper compatibility. For example, OMS 13.5 and Agent 13.5. Also, whenever you upgrade agent versions, please double-check RDS Oracle documentation for any patches or special configuration that may be required on the OMS. Now, our Oracle Native Network Encryption option allows you to specify SQLnet encryption properties for sessions connecting to your instance. But the server parameters only cover incoming sessions, not outgoing sessions such as database links. Now, with support for client parameters, outbound database links can also be encrypted. One thing to be aware of: the SHA-1 and MD5 checksum types are not included in the default values for the client parameters. You can still specify these explicitly, and you may have to if your server parameters use these algorithms. You'll need to always have at least one algorithm in common between client and server parameters. We certainly recommend staying up to date with the strongest algorithms available, but you'll need to decide what's right for your particular clients and environment. We've also added support for database time zone file upgrades. This file affects the daylight saving time behavior of timestamp with time zone data types inside the database. When you create an RDS Oracle instance, the database time zone file is based on the patch level of the initial version of your instance. As you apply minor and major version upgrades, the database time zone file is not upgraded. With the new time zone file auto upgrade option, you can now upgrade the database time zone file version either separately or as part of a database version upgrade. This process can involve significant downtime for larger databases with these data types, so we do recommend carefully testing on a snapshot restore first. And finally, we've added support for system diagnostic events via PL/SQL. RDS customers manage database parameters using RDS parameter groups, but these don't support the special case of the events parameter. This parameter is generally used to enable system-wide diagnostic tracing of a particular ORA error, generally at the request of Oracle support. With these new procedures in the RDS admin util package, you can now run alter system set events commands. Usage details and the list of allowed system events are covered in our documentation. Now let's talk about Oracle database versions. RDS Oracle supports major versions of Oracle database for as long as Oracle provides critical patches. When Oracle support discontinues critical patches, we deprecate the version and require customers to upgrade to a supported version. At the end of 2020, for example, we deprecated 11.204. And this year we've deprecated 18C. Next year we have deprecations coming up for versions 12.201 in March and 12.102 in July. If you're running on either of these versions, we strongly recommend that you upgrade as soon as possible. Also, keep in mind that when versions transition to extended support, bring your own license customers need to purchase extended support agreements or upgrade to versions covered by standard support. 19C is the long-term support release at the end of the 12.2 family, and the recommended version for all customers. This version will be supported through 2027, though bring your own license customers will need to purchase extended support starting in 2024. Now, we'll also be launching support for 21C shortly, but keep in mind this is an innovation release with a shortened support period. For most customers, 19C will be the right version for the next few years. The AWS forum post listed here is the authoritative reference for our detailed deprecation timelines, so please do bookmark it. We know that major version upgrades are no small matter, so we try to give you at least a year's notice when a deprecation is planned. This timeline is based on Oracle's own release schedule, though, which can change over time, so please be sure to keep an eye on it. Looking at RDS service level features, the team's been pretty busy here as well. For customers using the OEM agent option, agent logs are now available to help you with troubleshooting your cloud control configuration. You can choose to publish these to Amazon CloudWatch logs using the same mechanism that already supports alert and listener logs, as well as trace and audit files. Last year, we launched cross-region automated backups. This feature automatically copies and retains your database snapshots as well as transaction logs in a second region of your choosing. This provides a cost-effective disaster recovery strategy, allowing you to perform point-in-time restore in a second region with very little data loss. This year, we've expanded the list of supported regions and added support for at-rest encryption, both Oracle Transparent Database encryption, as well as Amazon Key Management Service storage encryption. Similarly, we've expanded the list of supported regions for R5B instance types. These instances provide the exact same CPU and memory as their R5 counterparts, but with 2 to 3 times the EBS bandwidth. For high storage throughput workloads, these can be a great benefit over R5s. This allows you to scale bandwidth without having to license additional vCPUs. And finally, we've added additional memory configurations for R5 instances. These are specific to RDS Oracle, and their names include additional information about Intel hyperthreading and the RAM configuration. These are helpful when you need to scale to a larger instance class for more memory or EBS bandwidth, but need to leave the vCPU count the same. For example, if you're running an R5.4 extra large and need double the RAM, you could scale to an R5.8 extra large. But you'd also go from 16 to 32 vCPUs, potentially increasing your Oracle licensing costs. Alternatively, you could switch to a different memory configuration for a 4x large. In the example here, that's a 4x large with 2 threads per core, indicating that hyperthreading is enabled, and 2 times the memory. So an instance that still has 16 vCPUs, but 256 gigs of RAM instead of 128. You can run an R5.4 extra large with up to 4 times the memory. That's 512 gigabytes for 16 vCPUs, a ratio of 32 to 1. The full list of instance types and their resource configurations is covered in our documentation. And finally, I'd like to mention RDS Custom. This is an entire topic to itself, but RDS has just launched a new deployment model, and we call it Custom. RDS Custom fits between EC2, where customers have to self-manage everything above the hardware, and RDS, where sometimes a managed service proves too restrictive. Custom expands the shared responsibility model and gives you the best of both worlds with RDS automation and limited ability to access and customize your instance. With Custom, the AWS resources used by your instance are deployed into your account, and RDS manages the instance using AWS Systems Manager. You can SSH to the host, attach additional storage, connect to your database SysDBA, and even modify some parts of the configuration. What makes this possible is the support perimeter. RDS automation monitors your instance and checks for any changes that prevent us from managing it. For example, if you change the sys password or block our agent from running on your host, you'll receive notification that RDS has detected that you are outside the support perimeter and some automation has been suspended on your instance. Looking at use cases, we think the most common use case for Custom is going to be packaged applications. Third-party software is sometimes inflexible in database permissions and patch levels, or may require other software running on the database host. Similarly, it should be helpful for customers looking to perform lift and shift migrations from on-premises, as well as hybrid DR environments with an on-premises database replicating RDS Custom using Oracle Data Guard. Like I said, Custom is its own topic with tons more to cover in terms of use cases, best practices, and current limitations of the service. There was an introductory breakout session for RDS. We think the most common use case for Custom is going to be packaged applications. Third-party software is sometimes inflexible in database permissions and patch levels, or may require other software running on the database host. Similarly, it should be helpful for customers looking to perform lift and shift migrations from on-premises, as well as hybrid DR environments with an on-premises database replicating to RDS Custom using Oracle Data Guard. Like I said, Custom is its own topic with tons more to cover in terms of use cases, best practices, and current limitations of the service. There's an introductory breakout session for RDS Custom at this year's reInvent that you should be able to find in the session catalog. And check out our documentation and blog posts for more information. We're really excited to see how customers use this new service. Now, let's take a closer look at 3 big features we've launched this year, starting with container database support. Since forever, Oracle's database architecture was built around a single monolithic database. The database itself was physically stored in separate data files, and objects could be organized into logical schemas, but there was one flat namespace for all schemas in the database. So you could have 2 tables named employees, provided they were in different schemas, but you could only have one schema named HR. Beginning with 12c, Oracle introduced a multi-tenant architecture. The existing database architecture was rolled up into a container database, or CDB, and additional pluggable databases, or PDBs, could be attached or plugged in to a container, all under a shared SGA and redo stream. Since forever, Oracle's database architecture was built around a single monolithic database. The database itself was physically stored in separate data files, and objects could be organized into logical schemas, but there was one flat namespace for all schemas in the database. So you could have 2 tables named employees, provided they were in different schemas, but only one schema named HR. Beginning with version 12c, Oracle introduced a multi-tenant architecture. The existing database architecture was rolled up into a container database, or CDB, and additional pluggable databases, or PDBs, could be attached or plugged in to the container, all under a shared SGA and redo stream. Each pluggable contains a lightweight data dictionary, mostly referencing the container's dictionary, and includes its own table spaces, schemas, and objects, independent from other pluggable databases. With this architecture, each PDB could have its own HR schema with its own employees table. For the most part, connecting to a pluggable database behaves the same as connecting to a non-multi-tenant database. And while multi-tenant support is an extra cost Enterprise Edition option, all editions will still end up on the container architecture, with a legacy architecture deprecated as of 21c. And so in RDS, until now, all instances have been built around that legacy non-multi-tenant architecture. Customers are provided a DNS endpoint, which they use to connect to a listener, which connects them directly to the database. As of this year, RDS now supports container databases in what we refer to as a single-tenant architecture. When customers create container database instances in RDS, your endpoint connects you to a listener, which connects you directly to the single pluggable database. You can specify the name of the PDB when you create the instance, or we'll use ORCL by default. You may also notice the container is always named RDS CDB. RDS takes care of managing the container database, so you can continue to focus on your applications. Again, everything inside the database behaves pretty much the same. The most notable difference is that you may need to replace system ID or SID with service names in your TNS connection strings. Otherwise, you should have access to the same privileges and most of the same RDS admin packages as a non-container RDS instance. A few things to know about using container databases. These are available in RDS beginning with the April 2021 release update of 19c. To distinguish them from non-container architecture, there's also new engine names. When using the command line or SDKs, you'll specify an engine name of Oracle-EE-CDB or Oracle-SE2-CDB for Standard Edition. In the AWS console, you'll check Use Multi-Tenant Architecture when creating instances. Similarly, there are CDB-specific parameter group names starting with 19c. RDS container databases are currently single-tenant, so there's only one pluggable database per instance. The container database is always named RDS CDB and is fully managed by RDS, so you won't have direct access to the container database or be able to create common users. Any actions that require access to the container are handled by RDS automation. For example, when you install RDS options on your instance, such as Application Express or Spatial, RDS takes care of installing the right components in the container and pluggable data dictionaries. With containers, snapshots behave exactly as they did before, with both snapshot restore and point-in-time restore supported. RDS snapshots capture the state of the storage underneath your database, so the container and pluggable are both included. The same holds true for multi-AZ, by the way, which replicates to another availability zone at the storage level, so there's no change in behavior for highly available instances either. And when you restore a container database instance, you can still change the database name, which in this case will rename the pluggable database. Now, with this new engine, there are still a few features that aren't supported quite yet. Namely, we don't yet support converting or upgrading non-container database instances to container database instances. If you need to do so for now, you can use Datapump or Amazon Database Migration Service to perform a logical migration to a container database. Replicas, either read or mounted, are not supported yet either. And several options are not there yet, including Oracle Enterprise Manager, Oracle Enterprise Manager Agent, and Oracle Label Security. So when should you use container databases with RDS? Well, some applications may require container database. This should work as long as they can work with a single pluggable database, but we do recommend that you carefully test functionality. Or perhaps for new development, you may want to start off with container databases to avoid having to convert in the future. For many customers, the primary use case for now will be to familiarize yourself with the container database architecture and see how applications work with container databases in RDS. Now for everybody's favorite topic, database auditing. Oracle Database has one of the most powerful and perhaps most complicated and perhaps frustrating auditing features in the relational database world. As DBAs, we often think of auditing as something we have to do, something imposed on us by compliance or corporate policies, and compliance is certainly an important use case for auditing. As a DBA, I've always found auditing to be a really helpful feature that gives you important insights into what's going on inside your database. Perhaps a user keeps getting locked out of their account. Well, to see where those bad login attempts are coming from, when they're happening, and any error codes that result, you'll need to have auditing enabled. Or suppose somebody dropped an important table last night. Auditing can tell you who did it, when, and from where, but you have to turn it on. Configuring auditing in Oracle is 3 steps. First, set your audit trail. This specifies where audit records will be written. Auditing is disabled by default, so you'll need to set this and restart your instance. Second, you have to define audit policies that say what will be audited. What actions, privileges, objects, and users will generate audit records. With Oracle, there's not really an audit everything switch, which is good because that could easily overwhelm your database. So you do need to be selective here. And third, you actually have to do something with your audit. Auditing isn't all that helpful if you just end up with millions of audit records that you never look at. You'll need something on the other end that looks for those invalid logins or whatever counts as a policy violation for your particular workload. Most customers use some sort of third-party database activity monitoring products for this sort of monitoring. Now let's take a closer look at that first step. With RDS Oracle, you have 2 main options for audit trails, either database or file system. When you set audit trail to DB or DB extended, Oracle writes audit records primarily to tables inside the database, and you access them using SQL and database views. When you use the database audit trail, mixed mode unified auditing is automatically enabled for 12.2 and later. Pure mode is not supported with RDS. The database audit trail is customer managed in RDS, so you'll need to use the DBMS audit management package. First, and I can't stress this enough, move the audit trail out of the system tablespace and into a tablespace of your choosing. Second, and equally important, define purge jobs to clean up old data. Again, it's easy to overwhelm a database with audit, so you'll want to closely monitor your space. If you fill your audit table space, you may get locked out of your database. Now, when you set audit trail to OS, XML, or XML extended, Oracle writes audit records to text files on the file system outside of the database. Each database process has its own audit file, which is continually appended through the life of the process. Retention of the file system audit trail is managed by RDS, with files automatically cleaned up after 7 days by default. You can modify the retention for trace and audit file cleanup, but you'll want to monitor space carefully. You can access these files from inside the database using PL/SQL or download them individually from the console, but for real analysis, you'll probably want to send them to another service such as Amazon CloudWatch Logs or Amazon S3. With RDS, just choose which type of files you want to publish to CloudWatch, and the service takes care of it for you. So if we look at how this is put together, users connect to a database where the DBA has defined an audit trail and audit policies. Their actions are written to the audit trail, which is either recorded into the database or to text files, which can be published to CloudWatch. From there, you'll still need to figure out how to maintain, monitor, analyze, and alarm on these audit records, which can still be quite a bit of work. This is where Database Activity Streams, or DAS, comes in. DAS is a new feature that automates the collection and processing of audit data generated by Amazon RDS and Aurora instances. For Oracle, DAS is built on unified auditing, so DBAs still need to define audit policies that say what will be audited. Every few seconds, DAS retrieves records from the unified audit trail, converts them to a standard log format shared with Amazon Aurora, sends them to Amazon Kinesis, and cleans them up from the database. This stream can be directly consumed by products such as IBM Security Guardium and Imperva SecureSphere. Alternatively, you can stream the records to an Amazon S3 bucket or process them yourself with an AWS Lambda function. So if we look at the architecture now, we still have a user connecting to a database where a DBA has defined audit policy and user actions are written to the unified audit trail. From there, DAS takes care of sweeping up audit records, encrypting them using Amazon KMS, pumping them into Amazon Kinesis, and cleaning them up from the database. Often customers can leverage the investments they've already made in third-party database activity monitoring products to analyze an alarm on the stream of audit information. A few things to consider when configuring DAS. First, the DBA needs to enable the database audit trail. Enabling DAS will also set the database audit trail, but doing it ahead of time can help you to test and make sure policies are configured properly before DAS takes over management of the audit trail. Next, again, define those audit policies. Oracle recommends using a minimal number of audit policies to reduce performance overhead, but exactly what actions you audit will depend on your business and compliance requirements. You should also clean up any existing audit data from the unified audit trail, as this will be purged when DAS takes control of audit retention. Second, the security administrator is responsible for turning DAS on and off. AWS Identity and Access Management context keys give you fine control over who can do this. Separation of duties is an important feature of DAS. Using IAM policies, you can ensure that the person who has DBA access to your instance can't turn DAS on and off, and the person with DAS privileges shouldn't be able to access the database or modify audit policies. And so some best practices for DAS. First, carefully define that separation of duties between DBAs and security administrators and make sure you know who can do what. Again, define your audit policies. Unified auditing does have overhead, so you'll need to strike a balance between auditing what you need without auditing too much and impacting performance. Each application is different, so the DBA has a very important role here in understanding how a particular workload is used and what sort of activity needs to be tracked to satisfy your requirements. You also need to get this right since audit policies are locked when DAS is enabled. If you need to modify policies afterwards, you'll need to have the security administrator disable DAS and then re-enable it when you're done, and that can result in a brief period of lost audit records. Next, you want to carefully test your particular workloads and configurations. Like I said, auditing adds overhead. If you're already running pretty hot and start auditing all activity in your database, there's a good chance that DAS won't be able to keep up and may fall further and further behind. In those situations, you'll need to either audit less or scale to a larger instance class with additional resources. Finally, monitor and alarm on any changes in audit trail space utilization, as well as changes in the status of DAS. Finally, let's talk about replica switchover. RDS for Oracle added support for in-region read replicas in early 2019. Cross-region replicas followed later that year, and mount mode replicas in 2020. While RDS refers to them as replicas, these are really Oracle DataGuard physical standby databases, fully managed by RDS, and running in maximum performance mode. DataGuard is an Enterprise Edition feature and does require extra cost active DataGuard licenses if the replica is open for read access. RDS manages the DataGuard configuration, including encryption. Log replication from primary to each replica is always encrypted, independent of any network encryption options you've configured on the instance. And each RDS Oracle source instance can have up to 5 total replicas, either read-only or mounted, and they can be in the same region or in different regions. Now, when we look at role transitions, RDS supports what we call promotion of the replica. When you promote a replica, replication is stopped and the replica is isolated. It's then converted from a physical standby database to a primary database and open for read-write access. In Oracle terms, this is activating the standby database. Your applications can now connect to the promoted replica and access it like an ordinary database instance. This is now a standalone instance that no longer has any relationship to the old primary or any of its other replicas. If this instance requires replicas of its own, either for offloading reads or for DR back in the other direction, you'll need to create new replicas from this new source instance. This can be especially challenging for DR drills where you need to switch to your DR region, but then switch back in a short period of time. And so to streamline that process, we'll be launching Replica Switchover shortly after reInvent. With Switchover, we'll now support the standard DataGuard switchover role transition. When you perform a switchover using the new RDS Switchover Read Replica API, RDS disconnects sessions from your primary instance and converts it from a primary database to a physical standby database. Your replica is converted to a primary and is open for read-write access. Replication resumes to existing replicas as well as the former primary instance, which is converted to an RDS Oracle replica instance. Once the switchover is complete, your application can connect to the new primary instance. Unlike promotion, we've kept the overall DataGuard configuration and simply reverse the direction of replication and swap the roles of databases involved. So there's no need to recreate replicas. Once any post-switchover action is complete, including your post-switchover backup and any other option group configuration, you'll be able to switch back as well. Simply call the Switchover Read Replica API again, and the roles will again reverse, converting the original source instance back to a primary. So now we have two options for role transitions. Let's talk about when to use them. Promotion is still helpful for any situation where you want a new instance with all of the data from a source instance. It's very similar to a point-in-time restore, but the replica is kept up to date with the primary until you decide to promote. You end up with a new read-write instance that's no longer related to the original source instance or its other replicas. For use cases where you need to shift traffic from one region to another and need the ability to switch back relatively quickly, Switchover is going to be a great new feature. With Switchover, the primary role transitions between a primary instance and one of its replicas. Replication automatically resumes to existing replicas, and you can switch back the other direction using the same process. This greatly simplifies planned and unplanned DR events. We expect to have Switchover launched in the coming weeks. So those are some of the features that the RDS Oracle team has been working on this year. Now, we always love to hear directly from our customers about how RDS fits into their world. So I'm very happy to turn it over to our customers at Goldman Sachs Transaction Banking. Over to you, Alistair.
My name is Alistair McDougall, and I run Cloud Engineering, which is part of the Transaction Banking Platform Engineering team. I'm going to give you a very brief introduction today, and then I'm going to turn things over to John Gorrie, who's going to go into a little bit more detail about what we do with RDS Oracle. Transaction banking is a business that provides a variety of payment and cash management services to clients. We started building out the business about 3.5 years ago now, and we're several hundred engineers in the US, UK, and India. We've built a highly secure and highly available cloud-native platform. The business was built from the ground up on AWS, and we use a broad variety of services from compute, database, analytics, messaging, and so on. RDS Oracle is one service that we've done quite a lot with, and I'll now turn it over to John Gorrie, who's going to go into some detail, as I said. John, over to you.
Thanks, Alistair. Thanks, Michael. My name's John Gorrie. I'm a vice president in the transaction banking business at Goldman Sachs, and I run database engineering. And I'm here today to talk to you a little bit about how we use RDS Oracle to build our next generation banking platform in the cloud. I have a traditional DBA background. I spent a long time at Goldman Sachs in the on-prem DBA world, and we've been using RDS Oracle in transaction banking for the last couple of years as we've been building out our platform. We use a multitude of different database platforms. We use Aurora, we use Dynamo, we use Elasticache, we use other third-party databases, but we do have several key components of our payment flow running on RDS Oracle, and obviously that's what I'm going to focus on today. Now, I could talk about RDS Oracle and how it's helped us for the next couple of hours, but I'm going to focus on a couple of key areas. I'm going to focus on the administrative overheads, the scalability, and availability, because these are where we think we've made the biggest strides using RDS and partnering with AWS. So starting with the administrative overheads, I have spent a long time in my previous career, and anyone who has spent a lot of time in the on-prem database world will have spent similar time worrying about infrastructure lower down the stack. So I have to think about OS patching 400 databases, or I have to worry about my enterprise storage array is filling up, and I have to worry about capacity and how I migrate those databases to new storage arrays and manage that capacity. RDS manages all of that on our behalf, and that allows my team to spend time working on the real value add functionality for our business. There's also the features of standardization. Michael mentioned parameter groups before. And using parameter groups across our estate means, again, we spend less time worrying about tuning individual databases and more time on standardization. So we like the fact that RDS Oracle provides us these defaults out the box, and that these defaults many times are tuned to the instance size and so functional with the instance size, so that even when we increase the instance size or change that, we don't have to go back and fine tune those parameters. They move with the instance. And again, that just means less overhead for us, less management for us, and more time for us to focus on the value add. Also, automated backups for point-in-time recovery. That's something else I don't have to worry about as a platform owner. I don't have to worry about the capacity for my backups. I don't have to worry about what happens if a backup fails and I have to monitor that and rerun it. I just turn on my automatic point-in-time recovery. I set it to 35 days in production, and I know that the RDS service is going to provide that for me, and I can roll forwards and backwards through time when I need to for recovery. And lastly, in this topic, the AutoMiner version upgrades. Oracle releases the patches every quarter, and then RDS makes them available sometime after that. And by setting the AutoMiner version upgrades to true in our lower lanes, it allows us to keep pace with those patches within 4 to 6 weeks of RDS making them available. We still like to control when we apply these patches in production because there is downtime associated with that. But in lower lanes, it allows us to keep the platform moving without having to spend time focusing on resources allocated to upgrades. Obviously, we have multiple lower lanes, many lower non-prod databases, and this just allows us to keep all of them at the front of the database patching without having to dedicate too much resources to that overhead. Moving on to talk about scalability. One of the things we really like about RDS is it allows us the ability to scale up or down our instance sizes with relatively small impact. In my old career, as you know, with an on-prem DBA background, when we have performance issues, when we have application business logic, application business surges, it's hard to pivot to larger instances. It's hard to dynamically grow or shrink the capacity allocated to a database. It's possible, but you have to put a lot of effort in and a lot of planning into coordinating that change. With RDS, we can quite simply increase the instance size and with a relatively low downtime, have that instance upsized, even in response to an ongoing event. We had a case just recently. We had a 4 CPU box where the application load spiked and it flatlined the database at 100% CPU. Now, we were not really able to see on the application side what was causing this. The application was running out of memory in conjunction with the database being at 100% CPU. We were able to, with relatively low downtime, increase that box from 4 CPU to 16 CPU, let the app load flow through, and then we could observe that it was actually consuming 9 CPU, and we could pinpoint where the poor application load was coming from, what the cause of it was. We could fix that application code, and then later we could put that instance back to 4 core, again, with relatively low downtime. So the ability to scale up and down, really, again, it just takes a load off of my team and allows us to focus on value add rather than database administration practices. Now I'm going to move on to talk about availability. We rely on both the in-region and cross-region availability options provided by RDS. Our primary resiliency method is multi-AZ within the region. So we rely on that automated failover. It's going to give us a second copy of the data in another AZ. And should we have a failure of that primary node, RDS is going to bring up that secondary node with a relatively short amount of downtime. AWS quote, I think around 120 seconds is typical in their notes. And anecdotally, we've seen that that is true. And so if our application is configured properly, with the correct timeouts and DNS refreshes and so on, we can actually have that failover happen with almost no application downtime. So that's one side of it. The other side is, we don't consider a failover to be complete until resiliency has been reestablished. And what that means is, we rely on, it's easy to promote the secondary node and start the application up. But then you have to worry about reestablishing your resiliency, because what happens if you get a failure of that secondary node? Multi-AZ allows us to have a third, or essentially a new replica created in a third AZ, transparent to us. So that's just going on in the background as part of the service. And that's a really powerful feature because it allows, again, my team can focus on the value add and not have to worry about how do we orchestrate failovers, how do we rebuild secondary copies of the data, and so on. Moving on to cross-region. Cross-region resiliency has been a big focus for us within transaction banking over the last 18 months. We have we have responsibilities to external regulators and internal and external auditors to prove our ability to fail the bank over and run from different physical regions. And so we've been working with the RDS team for how we build a cross-region resiliency for stateful services like RDS. So this is a diagram of what we build currently for our cross-region resiliency option. Now, we rely on the cross-region read replicas that Michael talked about earlier that was launched at the end of 2019. That's a kind of foundational cornerstone of this solution. So what we have here is we have a primary region in the same account as the secondary region, and we have our application deployed, and it's talking to a primary Oracle RDS database via a Route 53 CNAME, and we'll talk about why we use that in a second. And then on the right-hand side, we can see that we have Secrets Manager here as well to synchronize our database credentials. Now, when we initially started building this, replicated secrets were not a thing. Secrets Manager launched that feature earlier this year, and that's on our backlog to investigate and potentially slot that in here instead of our own solution. But for now, we have a Lambda that coordinates syncing secrets between regions so that if I rotate a secret in the primary region, it'll automatically replicate to the secondary region. And therefore, all my database credentials are going to be in sync between my primary and secondary regions at all times. And so in the secondary region at the moment, we have a read-only replica of the database, and we have our app stack configured in read-only mode, so it can talk to the database and run read-only operations if it wants to, and we can do canary checks and things like that. And its credentials are there in Secrets Manager. So this is our default state of build. And now we want to trigger a failover. Our failover orchestrator, which is not shown in this diagram, it's Lambda-based, and we trigger it through Systems Manager. And the first thing that we do when we trigger a failover is we trigger a promotion of that secondary replica to be a standalone database. Michael mentioned it earlier. So now, that database in US West, in our secondary region here, is now a standalone database. And now our application in US West can connect to it in read-write mode. Now that means the failover is effectively done from an application perspective, right? Business can resume at this point because our application is connected to the database in read-write mode. We've also, as we can see on the diagram here, broken our Secrets Manager replication because at the moment, these two regions are now currently standalone. But as I mentioned earlier, we don't consider a failover to be complete until resiliency has been reestablished. So we have to recreate our resiliency in the other direction. So what we do next is we build a new replica database back in the original primary region. We can't just replace the original primary database for a couple of reasons. Partly it's to do with the sort of infrastructure as code and AWS coordination. And partly it's because the replication cross-region is asynchronous, I may need that data later to manually reconcile if there was a hard failure and I did lose transactions. So I build a brand new replica in the primary region to reestablish my resiliency. You can also see that what we've done here is we've repointed the US East Route 53 entry to point to the new replica. So from an application perspective, even though there's a different physical RDS instance in this region, the Route 53 entry resolves to the correct one and it's seamless from an application point of view. We've also redirected the flow of our Secrets Manager replication so that rotations now in the US West region will be replicated back to US East. And again, that will keep our secrets and credentials synchronized between the two regions. And it has knowledge of which is primary and which is secondary at any one time. The last step in this is we go ahead and clean up that old primary database because we no longer need it. And now we are in a fully resilient mode. We have a primary region with a database replicating to a read-only region with a database, and all of our credentials are in sync. And that's how we built cross-region resiliency. Now, Michael talked about switchover. That is something that we expect will be a very powerful tool for us and will allow us to take out some of this customer-driven engineering. And we look forward to trying that when it's launched in a few weeks. And so I'm going to pass back now to Michael to wrap up. Thank you.
Thanks so much, John and Alistair. And thank you everyone for your time today. We've taken a look at some helpful new features that have launched with Amazon RDS for Oracle over the last year, focusing on container databases, database activity streams, and replica switchover. And we've seen how RDS helped Goldman Sachs create a digital-first transaction banking platform in the cloud. There's lots more to say about all of this, so here are some helpful references to help you on your way. AWS documentation is the first stop for everything you need to know about running services like RDS. Feature design, use cases, best practices, and command references are all covered here. AWS also has a large ecosystem of partners who are ready to help out with your migration. This blog from partner House of Brick covers many of the options for licensing Oracle on AWS. And our own AWS database blog is full of helpful content from our AWS solutions architects. You can check out the entire category, but I do recommend starting with the role of the DBA when moving to Amazon RDS. And finally, our RDS Oracle resources page has additional information, including case studies, papers, and other videos like this one. Thanks, and have a great day.